everyone, today I'm going to continue the same chapter which was discussed earlier. Now I'm continuing through the question number 10. Let's start. The question says, there is an opening in the container shown in the figure. Find the force P and the reaction at the hinge R. So what is given? Gauge pressure at the container is given, which is 24 kPa. Equivalent head of the oil due to 24 kPa pressure is also given. It is converted 24,000 upon 0.85 into 9810. This is the formula. We have to always calculate this if the gauge pressure is given. Then apply 2.9 meter of oil above the hinge. This is given by the formula as earlier. What is Y bar? Y bar is the 2.9 is the upper part. 1 by 2 is the always. It is the sine 30. And by calculating we get 3.2 meter. Then you should find the area of the gate. What is area? Area is the rectangular section having the width and depth is given in the question. So 1.2 into 1.2, 1.4. Then we have to do this as in the earlier cases we have done. Gamma A Y bar. What is gamma? Gamma is given 0.85, 9810. 1.2 is the area into 3.2 if we have get from Y bar. Then we got the value. Then let's also do YP. YP, how can we find it? Y bar plus Ig sine square theta upon AY bar. By substituting the value, we get the value of YP. Now, we have to again find the force vertical distance between hinge and R. So how can we find it? It is the YP minus we have got from the upper part, which is 2.9. Okay, inclined distance we can, how can we find? We can find by dividing by sine 30 degree. Now let's take the moment. How can we take the moment? We can take the moment by P into 1.2 is the distance minus F into 0.016. We have got the value. P is what? P is P. We have to determine the P. Now at last we have to do P plus R is equal to F. So from here we can find the value of R. How can we find R? P we have get from this. R is we have to find, and F is the force we have written here. So let's go through the question number 2 then. The gate AB shown is hinged at A as in the form of quarter concrete circle wall of radius 12 meter. The width of the gate is 30 meter. Calculate the force required P to hold the gate in the position. So it is the semicircular. Let's go through the area then. Firstly, how we can find the area? Through the rectangular portion, 12 into 30. So Y bar also we can find similarly 12 upon 2, depth upon 2. This is very easier. Then please go through F. How can we find F? Gamma A Y bar. Gamma is given 9810 into upper part A. Y bar is also given. Then you can find the force Fe. How can you find the force Fe? We can derive from the formula 9810 is the universal constant into pi d square by 4 into 30. How did 30 came? So here arises the question. It is none other than our width. Okay. So what, how and where does FV acts? FV acts at the distance of R by 3 pi from point 0. So substitute the value of R and 3 pi. What you get? Answer. You get answer. Again taking last moment P into 12 is equal to FH into 4 plus FV into 5. It is the horizontal and vertical forces. You substitute the value. You will get the answer. This was the gate numerical. Now you can again go through the manometer one. The bottle liquid in the figure of under pressure as shown by the manometer reading. Compute the net force on the 50 mm radius concavity in the bottom of the bottle. So what it says? You can find gamma L PAA value. Where you can find it? It can find it very easily. And at last what you have to do is equivalent head above AA. PAA divisible by gamma L. What is gamma? Gamma is given 0.9 into L is the length. Okay. Then you should add the both components and you get the answer. It's very easy. Now I have discussed the 3 questions. Okay everyone, this is the end for today. I will come in next chapter. Till then, take care.